Good morning all. Myself Mrs. M. Vijay Sabreshwari, working as an assistant professor in the Department of Electronics and Communication Engineering in Sri Shanmuga College of Engineering and Technology. So in this video I am going to explain about Ohm's law and KCL KVL laws. First one is Ohm's law. Ohm's law states that the current passing through a conductor is directly proportional to the voltage across its end and provided with the constant temperature under the physical conditions remain constant. So the expression is V equal to I into R, where V is equal to potential difference, that is voltage in volt, then I is equal to electric current in amperes, and R is equal to resistance in ohms. So this is the diagram. So the diagram explains the interrelationship between voltage, current and resistance. So this is the diagram, basic diagram. So the first under the diagrams we have a three types. So first one is used to find voltage, and the second one used to find the I, and the third one is used to find R. So look at the first diagram to find V. So the remaining terms are I into R. So I into R on the same phase. So V equal to I into R. In the second diagram, I. So V is at the numerator and R is in the denominator. So I equal to V by R. The third one, we need to find R. Again V is in the numerator and I is in the denominator. So R equal to V by A. So this triangle explains the interrelationship between voltage, current and resistance. From this triangle we can easily know how to calculate voltage, current and resistance if any of the two values are given and only one value is a unknown value. Next one is Kirchhoff voltage law, that is KVL. So KVL means the sum of voltages around a loop. So loop means a walking around and returning to the same point is called as a loop, must be equal to 0. So look at this diagram. So in this diagram we have a two closed loops, this one and this one. So in the first loop, we have a U1, U2, U3. There are three components are presented. So there is a voltage drop between, across U1 is V1 and across the U2 is V2, across the U3 is V3. So these are all the respective voltage drop across the elements. So according to KVL, so around the closed loop, the sum of voltage is equal to 0. So V1, V2, V3 equal to 0. Or consider this second loop, U3, U4, U5. So in the second loop, these are all the components and the respective voltage drops are V3 and V4 and V5. So V3, V4, V5 equal to 0. So this is in this loop, the direction is taken as a clockwise direction. So clockwise direction, this is the plus, minus 2 plus, this one is also minus 2 plus, but U3 across the V3, this is the plus to minus. That is why here it is mentioned as minus V3 plus V4 plus V5 equal to 0. So other than these two loops, consider U1, U2, U4, U5. Neglect the U3. So this also can be considered as a closed loop. So according to KVL, the respective voltage drops across U1, U2, U4, U5 are, here it is a minus 2 plus, so plus V1, here also plus V2 plus V4 plus V5 equal to 0. So these are all the three statements which explains the KVL. So for the polarity of voltage, it must be consistent as you go around the loop. Obviously, when you solve, we find a voltage to be negative, which means you need to flip or reverse the polarity. Next one is Kirchhoff current law. So current law means at a node, the sum of current equal to 0. The current flowing into a location, that is a node, must be equal to the current flowing out of the location. So whenever the current is entering into the node, the same current will be leaving to other branches of the circuit. So that is the KCL. So or put another way, the sum of current at any location must equal to 0. So consider this diagram. In this diagram, take this as a nodal point. So I1 current is entering from this branch, but other than these two branch, I2 also is leaving, I3 is also leaving. So I1 is equal to I2 plus I3, or I1 entering current should be taken as positive and the leaving current should be taken as negative. So I1, that is entering current, minus I2 minus I3 because these two are leaving current. So I1 minus I2 minus I3 equal to 0. That is your KCL. Kirchhoff current law. So KCL says whenever the current is entering, that should be leaving. So otherwise, here at your node both the currents are entering. That means I1 plus I2 equal to 0, or I1 is equal to minus I2. So or the current, both the currents are leaving, then means I minus I1 minus I2 equal to 0, or I2 equal to minus I1, or I1 plus I2 equal to 0 when one current is entering and another current is leaving. So I1 equal to I2. Here also I2 current is entering, I1 current is leaving. So I2 equal to I1. So where we can apply? So whenever we are solving in electrical circuit to find voltage or current, that is very useful to apply KVL and KCL. So in this circuit, this is a simple circuit with one loop and one current. So if you are applying KVL, we can easily find the respective current for this circuit and the respective voltage across is the resistor. In the same way, this is the second circuit. When we solving this circuit, we have a three current I1, I2, I3. So when you are applying KCL, we can easily find out the I1, I2, I3 values. So this is the example formula problem to understand the concept. So find the voltage across 3 ohm resistor using KVL. So this is very simple because across the 3 ohm resistor, what is the voltage drop is same as that of the voltage across the 6 volt. So if you are changing the polarity, the same voltage drop will be occurred. So that is mentioned here. So if you considering this loop means 9 voltage, and this one is we don't know, and this is we know minus 6 volt. So minus 9 minus 6 voltage is equal to 15 voltage. So that is the voltage drop across the 4 ohm resistor. The next problem is for KCL. Then at your node, the sum of currents equal to 0, or another statement is incoming current is equal to outgoing current. So look at the diagram. The incoming currents are 0.6 ampere, 0.7 ampere, 0.2 ampere. Then the leaving currents are 0.5 ampere, I, then 0.4. So if you are solving this, we will get the I value is equal to 0.6 ampere. Then try to solve this problem by using the Ohm's law. So according to the Ohm's law, V is equal to I into R. So this is a very simple circuit having a single loop. So in this loop we have a supplied voltage 48 volt and the resistance value 12 ohm, 14 ohm and 13 ohm. So directly we can apply. So all the three resistors are connected in series. So if the resistors are connected in series, we can easily converted all the three resistor into a single equivalent resistor, and the single equivalent resistance value is calculated by sum of the three resistor R1 plus R2 plus R3. So that is 39 ohm. So all the three resistors are replaced by a single resistance 39 ohm. So now we have a supplied voltage and V and resistance. So the I value is equal to V by R. So 48 divided by 39, it gives the answer. Thank you.